Okay, good morning, everyone. Good morning also, Pak Hendra and Pak Wamiki. Today we will still discuss about the water treatment process. Last time we have discussed the external treatments until the clarifiers. So now we go to the filtration process. I think you're already familiar. With this process. Filtration is still categorized as the external treatment for the water treatment process, and it is in the group B. The function, I think you already know, filtration is used to remove suspended solids. So the suspended solids will go, the water that containing suspended solid will be flowing to the filter. Yeah, it goes to the porous layer. It can be sand or some other materials like anthracite, carbon, or other materials. So the water will go through the porous layer. Yeah, the filter will have certain pores with certain size, and then the water will go through the porous layer, and then the suspended solid will retain on the surface of the filter. So depending on the size, if the design of the filter is to choose what is the size of the pore. Yeah, the size of the pore. So the suspended solid must be the size of the suspended solid must be higher than the filter pore size. Then,
yes. Never mind. Your voice was really low before, but it's now all right again.
I don't know. It happened since yesterday. You can ask Kevin during yesterday's class in DSPP. It also happened. I think it's Zoom and my Wi-Fi provider. How about now?
It's fluctuating, sir.
It's fluctuating. Okay, just a minute. Yeah. Okay. And during the operation, normally a filter will operate only for this limited time, because you will have accumulated of suspended solid on the filter surface, and the accumulation will create a pressure drop. It means during the time, the flow rate of the clean water through the filter will decrease. Yeah, the flow rate will decrease, and it will decrease along with the increase of the pressure drops. And if the pressure drop reaches a certain value, then you won't get any filtrate. You won't get any clear liquid. Yeah, it means the filter is already been clogged, and we have to do the cleaning. Or we used to say the procedure is the backwash. So you clean up the suspended solid on the surface of the filter. So basically, in industry, we have different types of filter. This is the normal gravity filter. Yeah, I think some houses, when the well water is not good, some install the gravity filter. So it's like the outer box is like the tube, and then it is filled with certain materials, including sands, with different size. Different size creates different pore size, right? Because it's solid, so it will create the empty space, the void space, and then it can be used to filter the water. Okay, this is the usual sand filter. And then we also have pressure filter. So these pressure filters is basically use pressure to overcome the pressure drop, the pressure drop that happen in the filtration process. Yeah, but because it's pressurized, so the container or the outer container has to be really in a good closed condition, because it has to sustain a certain pressure. So it's well, the operation it's okay. It requires less space, and then it's easy to install. Yeah, and then less water pumping, because it's helped with the pressure. But however, the disadvantage, it will be difficult to check what happened inside the box, yeah, because it's not designed to easily open and close. Yeah, you can open, but you can open during the maintenance. Yeah, this is the pressure filter. And then another type is the Upflow Sandfilter. So it's still using the outer dimension or outer looks is like this one. The inside one is like this one. It uses sand, and then the water will flow from the top part. Then it goes to this one, the gray one, and then you have this one. This one is like a perforated tube, and then the water will flow. The water will flow up. The brown one is the sand, and during the flow, the sand will act as the filter. Yeah, so it will create the clear water, the blue one, and then the clear water will flow through this part. Some water which were not filtered perfectly will goes down, and then it will pump up to the top part. So this one is the remaining of the water that cannot be filtered perfectly. Okay. How about the sound? Is it still okay or still fluctuating?
It's okay now, sir.
Okay. I don't know exactly. I think some problem with the microphone or the Zoom. Okay. The next one is the most common process in water treatment, which is ion exchange. So ion exchange is basically it is a physical chemical process, yeah, because the physical and chemistry process happen during the ion exchange. So if you have water that has certain dissolved solid, yeah, certain dissolved solids containing minerals, then if you want to remove that minerals, because when the minerals is dissolved in the water, they will form like the ionization condition. So either it's positive or negative, which part of the ions that you want to remove, then you can use either the cation exchange cation exchanger or cation exchange resin, or anion exchange resin. Yeah, in this process, the resin is in solid form. Yeah, in the insoluble form. It will accept the positive or negative ions from the solution. Yeah, it will take the ions, and then it will release other ions. So if it accepts the cation, then it will release another cation to the solution in the same amount. Yeah. So if the exchange ion is the cation, it will be the cation exchange resin. If the exchange ion is the anion, the resin will be anion exchange resin. So the example of the reaction is like this one. So HR and ROH is the resin. This one is the cation. This one is the anion. For example, you want to clean up the water with containing calcium chloride. Then the solution of the water, the aqueous solution of calcium chloride, will be reacting with the cation exchange resin, and the resin will take the calcium ion and release the hydrogen ion, and then water will become containing its HCl. And then for the anion exchange, the resin will take the sulfate ion. Yeah, the resin will sulfate the sulfate ions and then release the hydroxide ion and becomes sodium hydroxide. Okay, from the reaction you can understand that because we put the resin inside the column, and then the water will flows through the column, and while flowing into the column, the resin will work. It means the reaction will happen. So if you have a lot of water treated, because the amount of resins placed in the column is limited, right? So if you have a lot of water that's being treated, the resin will be saturated. It means they won't have any either the hydrogen ion or the hydroxide ion. So it got saturated, and it should be regenerated. Yeah, can be using acid or base solution depending on the types. Yeah, I have provided the video, but I will not play the video. It's just short video to help you understand. You can check it from the Unex. Okay, so basically the ion exchange based on the reaction, it can be used to treat the hardness. Yeah, the hardness, because hardness comes from the calcium chloride, for example, or from the calcium carbonate, and then it can be used to treat the hardness, to reduce or to soften the water. Or if you for the boiler that classified as a high pressure boiler, because in high pressure boiler it will require very high. It will produce high temperature, so the water should not be containing any minerals. So ion exchange can also be used to take all the minerals from the water. Yeah, it so become the demineralized water. Okay, the resin, it's very small solid particle. It's around 400 until 800 microns. Okay, any question until this part? Maybe from the explanation for our last class, if you have any question. Or maybe from Pak Hendra, if you have anything to add. Oh, I think Pak Hendra have another class parallel with this class.
Ya Pak, hadir Pak.
Okay, so Pak Hendra, do you have anything to add?
Maybe I have one simple example, Pak. For example, in my house, when I want to clean the water, I use the rub ash, Pak, the abu gosok.
Okay.
Rub ash is one of also the good filter, to use it for cleaning the water. But it is actually based on same functions with the sense, But I don't know. I get the information from my father that using abu gosok is much more clean, the water. So I have to find out why abu gosok can actually make the water is clean. But in the real applications, but when I try different types of the filters, it gives kind of the different quality of water, Pak.
So
but
do
abu
you
gosok
install
is the
it
best
by
one.
yourself, Pak Hendra?
Install it in my torrent, Pak.
So you put the abu gosok inside the torrent?
No, but there's actually one additional
tube, right?
One additional tubes, Pak.
Yeah.
So we need one additional tubes, and if we just put directly the abu gosok in the torrent, it will, of course it will goes with the water, Well, we need kind of the additional tubes in order to put all of the abu gosok inside the tubes, and the water will just flow through the tubes, and then after that the waters will become more clean.
Yeah.
This is a simple example, and you can try it in your home, maybe. Just
I think so. Yeah, they can try it.
Pak.
Or maybe the student actually have this similar tube at home. Maybe just they don't realize. Because in area that have bad condition of water, like in our area, Pak Hendra, in western part of Bandung, the water is not good. We normally install a filter, and it's not only sand, correct? Actually, you can buy the filter arrangement. I think some ada toko yang jual gitu ya, ada perusahaan yang jual skala rumahan. The content will be the sand, and then some charcoal and some abu gosok. It's a stack of that kind of staff to do the filtration. Yeah, okay, thank you, Pak Hendra. Any question from the student? Okay, if you have no question, then I will continue. Okay, the other technology that currently has been widely applied is the membrane. Yeah, I think. Have you take? Do you take any? Do you take membrane class, the elective?
No, sir.
No. Okay, I think if you want to know the detail about the membrane, you can take that class, or maybe you can read from the slide. You can ask Bu Helen. I think Bu Helen is very resourceful regarding membrane. Bu Helen or Pak Udin. Of course, Pak Wenton is the master, the professor of membrane. Okay, this membrane is basically there's a lot of quite types of membrane, and membrane in industry can be used first as a substitution for the coagulation and flocculation process. So if in coagulation and flocculation, hopefully you still remember, you need to add the chemicals, right? You need to add chemicals. You need to provide the mixing, different degree of mixing. First, you mix it quickly, and then you have slow mixing and continue with the clarification process. Yeah. In using the membrane, you don't need to add the chemicals. You just need to provide the membrane. You need to choose the correct membrane. Membrane is basically similar with filtration. Yeah, if the membrane is of, I think you still remember. One is dead end filtration, right? The one with the filtration is the dead end filtration. If you are using the membrane, actually it will come cross flow or tangential filtration. What will be the benefit of the tangential filtration? The accumulation of the cake, yeah, the cake that we said, the suspended solid that accumulated on the layer of the membrane will not as much as the dead end filtration. It means it can be used for a longer duration because the pressure drop is not it will increase, the pressure drop will increase, same with the filtration, but you can use it in a longer duration because of the flow type when you use the membrane. So you can use it as the substitution for coagulation and flocculation. Of course, it's the filtration, and then you can use it to because the materials or the stuff inside the water that you may want to separate it is the suspended solid in water that can create hardness. So with the membrane, you can use it to reduce either the suspended solid or the dissolved solid in softening process. And of course, now is membrane is widely used for demineralization process. So it can completely reduce all the minerals. It can eliminate the minerals inside the water, contained in the water. We call it reverse osmosis membrane. Yeah, depending on the size, I think you have heard about the microfiltration and then ultrafiltration and then nanofiltration. So it is the classification of membrane based on the pore size. It means if the pore size is different, it will operate with different suspended solid size. Yeah, depending on the size of the suspended solid, then you can use the correct membrane depending on the size. And then membrane can be operated with the what we call we add some electricity. So we can do the electrodialysis or deionization. Yeah, it's the combination of the membrane operation with the electricity. And last one is that I have mentioned before is the reverse osmosis. Yeah, normally membrane, it's the same with the filter. Yeah, the arrangement, just the flow type is different. Yeah, it is packed in the you can see it can be like the pressure filter that we have discussed before, or it have the tubular arrangements like this. Yeah, the arrangement of the membrane can be flat membrane, or I think maybe you have heard like flat membrane is basically like the filter, and or the spiral wound. So it's like the tube, and then inside the tube you have very small membrane, like sedotan. Sedotan is what in English? Yeah, it has the very small diameters, like a very small pipe, but made from polymer. Yeah, basically made from polymer, and then water will goes through the inner side, and it will filtrate the water outside, and then it will be collected on the other side. Okay, so the membrane configuration, basically you can see it can be from inside to outside. Yeah, like I've told you before. Yeah, this is the membrane. Yeah, this is the membrane, and then the raw water goes inside the membrane, and then the clean water will goes from the outside part, or vice versa. Yeah, this is the raw water, and then the clean water will accumulate inside and will be collected at the other end. Okay, the one that has been used recently is the reverse osmosis. By the name, I think you can get the concept, right? It is the reverse of the osmosis process. What is the osmosis? Do you still remember? Apa itu osmosis?
Sir, is it the
Yes.
movement of water from higher water potential to the lower water potential?
Is the movement high water potential?
To the low water potential.
What is a high and low water potential?
Where the the area of where there is more water.
Yeah, actually it's the opposite of diffusion, right? If you have diffusion, the one that move is the solute. Yeah, solute is the component soluble inside the water. Yeah, it will goes from high concentration to low concentration. Is the diffusion. Ya, yang bergerak itu yang terlarutnya, komponen yang terlarutnya, the one that diluted into the water from high concentration to low concentration until reach balance. Ya, osmosis ya, is the reverse. So if you have, I think that's what you mean with high potential, right? If the water have a lot of dissolved solids, you call it high potential, and then you have a membrane, and then you have pure water. Yang bergerak adalah pure waternya. Yeah, from actually it should be low potential to high potential. Am I correct?
Sir, from what I've been taught, the high water potential is
Pure water.
Pure water, yeah.
Ah, okay. Then this is high potential. This is low potential. Yeah, but basically the one that move is the water. So water will move from here to here through membrane. Okay, our purpose is to have clean water, right? So if just the osmosis, basically this is not the process that we want, because the water will go to the other part. Okay, the concentration of this part will be lower, but you won't get pure water. So in reverse osmosis, we apply the pressure. Yeah, we apply external pressure to encounter this pressure. So when water flows from the right side to the left side, it will create the osmosis pressure. That's why we apply the pressure to encounter the osmosis pressure. So the flow will be in the opposite direction. From the raw water will containing dissolved solid, the water will go through the membrane with the pressure, yeah, overcoming the osmotic pressure, and then you can have clean water. That's the basic principle of reverse osmosis. And now reverse osmosis is widely used, for example, is for the desalination process, yeah, to get the fresh water from seawater. Okay, so these are types of external water treatment. Yeah, we normally call it water treatment. Before the water can be used either for boiler feed water or maybe for the cooling tower water or any other, maybe for the heat exchanger for cooling water. Yeah, depending on the specification of the equipment, the specification of the water will be different, and of course it will require different treatment. Okay, any question until this part? Okay, now we go to the second types of treatment. We call it internal treatment, because in internal treatment, the water treatment will be used depending on the purpose. It's more specific, ya. Jadi internal treatment itu pengolahan yang lebih spesifik lagi, ya, tergantung kebutuhannya nanti seperti apa, ya. Internal treatment is performed, ya, to the water depending on the system criteria, ya. It's we will adjust. That's why we call it water conditioning. We will adjust the water condition by adding chemicals. So normally in internal treatment, we are using chemicals. Types of chemicals will be different depending on the purpose. Yeah, basically the chemicals will react with the impurities. So the impurities will not cause any disturbance if the water will be used. Okay. For example, to prevent corrosion, then corrosion can be occurred when the dissolved oxygen in the water is quite high. Then we add either the sodium sulfide or chemicals named hydrazine as oxygen scavenger. The name is oxygen scavenger, is to remove the oxygen. Or if you have suspended solid or maybe chemicals that may accumulate on the surface of the equipment, like the tube of the boiler, then we can add other chemicals to remove the accumulated stuff. Yeah, we call it mud properties that could that attach to the metal equipment. It can be removed by adding the organic. Yeah, the purpose why we add this organic is to dissolve the mud. Yeah, so this is the purpose of the internal treatment. First is to react with the hardness component in the feed water. So the purpose is to prevent the precipitation, because hardness can when the water is being boiled in the boiler, the temperature will increase, right? It will evaporate, and the concentration of the suspended solid, or sorry, the dissolved solid will increase. Yeah, so it will precipitate. We don't want this one, so we add the chemicals, or it can be used to convert the suspended solid, like hardness in the form of mud and iron oxide, so it can be converted to other compound, and this compound will not be layering the metal surface. Or we can add the foam, yeah, anti-foam. Foam comes from the organic component in the water. So if it's being boiled in the boiler, and also due to the flow rate, the organic components will create foams. Foams, it's the type of the suspension, right? So it may, if you have foam in the boiler, it may be carried over to the next process. So the steam will carry the organic component. This is, we do not want it, because it will create problems in the subsequent process. Yeah, so to prevent the carryover due to the foam formation, we add the anti-foam. Okay, the last one is I think I have explained to you. We might want to remove the oxygen from the water in order to prevent the corrosion. Yeah, this is the basic process of the water conditioning, or the internal treatment. Okay, I think this table will summarize the internal process, internal water treatment. Yeah, basically is to adjust the pH, yeah, to inhibit the scale formation, to disperse the mud or the sludge, yeah, to clean up the oxygen, to reduce or to eliminate all the oxygen, to prevent the foam, and to prevent the corrosion. Yeah, several chemicals can be used for its purpose. Any question until this one?
All good so far, sir.
Maybe I did not explain the details, but if you please read from the textbook, the Kurita handbook. Yeah, these materials comes from the Kurita handbooks. If you need the details, you can read the handbook. Okay, now we goes to the water treatment and chemicals for the boilers. For boilers, you will have the discussion in details later after this part of the lecture. Yeah, about the design of the boiler, because we have different types of boiler. And then basically boilers are classified into three different operation depending on the pressure. It can be classified as low pressure, medium pressure, and high pressure. And because the pressure is different, please remember again your thermodynamic class. Then the steam that produced by this different type of boiler will also have different specification. The pressure will be different. It means the temperature will be different. The phase will be different. It can be saturated steam, it can be superheated steam, or it can be super saturated steam. Yeah, it means the temperature and the condition of water and vapor in the steam will be different. And the temperature, and because the pressure will dictate the temperature difference in boiler will create different problems. So for low pressure and high pressure boiler, the one that we need to pay attention is a bit different. And it will, and since it's use different types of water, yeah, boiler feed water for low and high pressure is usually different. Although you can use the same type of water, it means the water for the high pressure boiler, but for low pressure, normally you do not use a very I mean, for example, if for high pressure boiler, usually we use the really demineralized water. But for the low pressure, we just use the softened water. So the problem will be different. Okay, so we know, I think before I explain about the problems, common problems in the boiler related to the boiler feed water, maybe I can show you some short video.
Explain boiler feed water and give its specifications. Generally, boilers are used in industries to generate steam, which in turn is used to generate power and heat. Thus, boiler is a device for generating steam. It consists of two main parts, furnace and boiler proper. Furnace provides heat by burning the fuel. And boiler proper is a device where water changes into steam due to heat. This steam or hot fluid is then recirculated out of the boiler to be used in various processes in heating applications. The water which is fed into the boiler is called the boiler feed water. These days, modern boilers require high-quality water to operate efficiently. But such water can never be obtained from any of the natural sources, as it contains certain impurities. The presence of impurities in the water makes it unfit for use in the boilers. So to make the water fit for use in boilers, it should be pre-treated using various techniques. Thus, we can say that boiler feed water is specially conditioned water which is fed into the boiler to generate steam or hot water. It is generated through a system of heat economy. Steam produced in the boiler is condensed after use and is returned as pure feed water called the return water. Then some fresh water or make-up water is added to this return water. It is this combination of return water and make-up water which is fed into the boiler as the boiler feed water to generate steam. Note that boiler feed water depends upon the quality of the make-up water and the amount of condensate returned to the boiler. Sometimes we see that some impurities settle down at the bottom of the boiler after the steam is produced. We know that steam which escapes from the boiler normally contains liquid droplets and gases. So the remaining water at the bottom of the boiler might pick up all the foreign matter from the water that was converted to steam. This results in the accumulation of impurities at the bottom of the boiler. These impurities can be removed by discharging some water from the boiler to the drain. Such process of blowing the impurities from the boiler to the drain is called blow-down operation. In order to operate and maintain a boiler system efficiently, it is important to treat the boiler feed water properly. This is because when steam is produced, the dissolved solids become concentrated and form deposits inside the boiler. This leads to poor heat transfer and reduces the efficiency of the boiler. Also, the dissolved gas, such as oxygen and carbon dioxide, react with the metals in the boiler system, and this leads to boiler corrosion. Thus, to protect the boiler from such contaminants, the boiler feed water should be treated properly through external or internal treatment. Let us now discuss the specifications of boiler feed water. Before using the boiler feed water in the boiler, it should be made sure that it meets the following specifications. Its hardness should be below 0.2 parts per million. Its caustic alkalinity should be between 0.15 and 0.45 parts per million. Its soda alkalinity should be between 0.45 and 1 parts per million. It should be free from turbidity and sediments. And it should be free from organic matter, oil and grease to avoid foaming. Note that in thermal power stations, feed water is usually stored, preheated and conditioned in the feed water tank and then forwarded into the boiler through the boiler feed water pump. Related terms are
Okay, hopefully from the video you can understand better. Yeah, this video explained to you the part of the boiler. So you have a furnace at the bottom, and then the boiler topper, and then the top part will be when the steam is flowing to the next process. And basically, there are 3 common problems that encounter in boiler operation. Okay, before I continue, is the sound still okay now? Suaranya masih jelas atau kecil?
Kecil banget sih.
I don't know. How about now?
It's still really small, sir.
How about now? Is the sound still okay?
It's still really small, sir. I have to like put up my volume to like maximum to hear you, sir.
Okay, let me check.
Okay, it's back to normal now, sir.
It's back to normal, sir.
Yeah, is it okay now?
Yes, sir.
I don't know what happened with my Zoom. Okay, let's continue for a bit. Yeah, this is the common problem the boiler normally have. So once it's scaling, yeah, the scaling is basically due to the hardness or any component that sticks to the surface of the either the heating tube or the other parts. So if scaling happen, then what happen? The efficiency of the boiler, thermal efficiency, the boiler efficiency will reduce, and the major problem will be the bursting of the evaporation tube, because the scaling can create what we call embrittlement. Yeah, I think in kuliah corrosion construction material, bakon, I think you have heard about the embrittlement. Yeah, scaling can cause the embrittlement. The second one is the corrosion. Yeah, the corrosion will of course damage the piping. Yeah, it will damage the piping. It caused by the dissolved oxygen or other component like carbon dioxide, because if it's dissolved in the water, it will create the acid condition. Yeah, and then the corrosion will also reduce the thermal efficiency and also damage the tube. Okay, and then the carryover. The carryover is the one that influence the steam purity. Yeah, the steam will not be as good as if it's not if the carryover is not happening. Yeah, and then if the silica, the silica component, hopefully you still remember about the silica's problem. If it's carry over to the steam, then the silica scale will reduce the turbine. If the steam is used, subsequently used in a steam turbine, then the silica scale will reduce the turbine efficiency, and then also the component in the steam will deteriorate destroy or deteriorate the product quality that treated with the steam. Yeah, this is the common problems. Yeah, cause of and this is the cause of the troubles. The scaling are from the hardness, and this one is from the oxygen. It's basically happen when you have fluctuation of the operation load. Yeah, the heat supplied is not constant, and then we have the excess concentration of boiler water, and also when the boiler water is contaminated with the organic matters, so it will have a carryover. Yeah, this is the scaling. Yeah, you can imagine if you have the tube wall, and at one part the tube is being heated. Yeah, so it will be a localized heat at the other side of the tube. And then if you have, for example, the dissolved solid that causing hardness, if you have localized heat in this one, then the deposition of it will create the concentrated film, and the dissolved solid will start to accumulate on the surface of the tube. And this is the example of the substance. It can be in silica, it can be in calcium carbonate or other stuff. And if you compare, the tube can be made from the steel. This is the carbon steel or copper. And you can see from the copper is of course having a better thermal conductivity than steel. But if the scale is covering the tube, then the thermal conductivity will be much lower. Yeah, it will influence the heating process, and of course it will influence the steam production. Okay, this is the example of the scaling. Okay, types of scales quite different, between low boiler and high pressure boiler. So for the low boiler, usually we use softened water, or maybe fresh water. So the main component of the scale will be the calcium oxide or from the magnesium oxide. Yeah, it's quite significant in low pressure boiler. But for the high pressure boiler, because in high pressure we already use the demineralized water, so the problems normally comes from the iron oxide or from the corrosion scale. Yeah, the corrosion itself, it can happen. I think for the deal of the corrosion, you can also take elective course about the corrosion. I think Pak Hardev and Pak Pram will teach that lecture. So corrosion can comes from this part. So from the boiler feed line, the boiler feed line, if the pressure of the boiler is quite low, yeah, for low pressure, is basically the corrosion problem is lower compared to high pressure, because corrosion is much more significant when the temperature is high. But however, in the boiler system, sometimes we install economizer, or I forgot the name, preheater, yeah, to increase the temperature of the water being fed to the boiler. So reducing the beban, reducing the boiler requirement, yeah, to increase the temperature. So we can increase the feed water using preheat, increase the temperature using the preheater. It means that the temperature is increased. Yeah. So if the temperature is increased, then the corrosion problem is more significant. Yeah, this is the reaction of the corrosion. The corrosion can this is the corrosion that happened in the pipeline, in the feed water line, yeah, before entering the boiler, or the corrosion can also happen inside the boiler. Yeah, it can be due to the dissolved oxygen, due to the precipitation of the corrosion product, and due to the alkali concentration, or we call it caustic corrosion. And also, the corrosion can happen after the boiler in the condensate line. Yeah, this is also because of the hardness and also from the oxygen. So basically, how to prevent the corrosion? First, you can adjust the level of the hardness using the softening method. Yeah, decrease the carbonate in the water, and also adjust the pH. Yeah, however, for pH, it's like two sides. If you increase the pH, it means the possibility of scaling is high. But if you decrease the pH, the possibility of hardness is lower, but the possibility of corrosion is higher. Yeah. And then for corrosion, you can add what we call chemical. We call corrosion inhibitor. Yeah, they will form certain film on the surface of the tube or on the surface of the boiler proper, so to reduce the possibility of the corrosion. And of course, you can reduce the dissolved oxygen by using the oxygen scavenger chemicals. Yeah, I think I won't explain in detail about the corrosion mechanism. If you are not, if you are interested, you can take the corrosion class. Yeah, but basically this is the mechanism of the corrosion. The chemicals or the dissolved solid in the water will create localized corrosion is electrochemical reaction. So it happen with anode and cathode. So some part will act as the anode, and some part will act as the cathode, and the reaction of the corrosion is occur. Yeah, or the caustic corrosion, or we call it gouging corrosion. By the name, the corrosion occurred happen due to the deposition of sodium hydroxide. So if the water consists sodium hydroxide, it can disrupt the protective layer of the metals. Yeah, the protective layer of the metals, it will sticks, and when the water is being heated, it will evaporate, right? So the materials will accumulate, the sodium hydroxide will accumulate at the surface of the water, and it can cause embrittlement. Okay, in details, please read the textbook, because it's just I think it's easy to understand. And the last one is the carryover. I think we have discussed, yeah. So some dissolved substance can be transferred to the steam. Why? First is because of the inconsistent boiling process. We call it the priming. The priming is the first process of starting up the boiler. At that time, the heat supplied by the furnace is not constant. Sometimes it's very, very high. So it can cause the rapid increase of the heat load. It will form water droplet and foams, and it will transfer together with the steam. The water droplets will bring the unwanted dissolved solid. Kan harusnya kalau penguapannya bagus, kalau pemanasannya bagus, hanya air yang menguap hanya air yang menguap jadi steam. Tapi karena ini pemanasannya tiba-tiba tidak konstan, jadi yang naik itu tidak hanya uap tapi droplet air. Droplet air membawa yang tadi materi yang seharusnya mengendap, sehingga nanti ikut terbawa di steam. It can be carried over to the steam. And also due to the foaming. Foaming is due to the organic stuff, organic matter in the water. It's same like water droplets basically. So in the foam is liquid in gas, right? Liquid in gas or gas in liquid, I forgot. Basically, the process is like droplet. So it will bring up the unwanted dissolved solid to the steam. So it will carry to maybe to the turbine or to the next process. Okay, I think this is already explained to you. So this is the summary of the internal treatment. Okay, any question or any addition from Pak Hendra? It's already 9 o'clock basically.
Yeah, Pak, I think additional information here regarding the way how to prevent the corrosions in boiler, I think is tabulated in this table. So please, students, pay attention regarding the chemical names, chemical use that is actually commonly used in the plants. For example, oxygen scavengers, usually we use sodium sulfite and hydrazine. And also we have also the inhibitor based on the molybdate and nitrate, I think, if I'm not mistaken. But in here also we have ammonia, morpholine, and so on. So I think it will be better for the students to take a look in especially for the several chemicals that is commonly used in real industrial applications, for preventing the corrosions, especially in boiler or in the pipeline. And another way to prevent the corrosions, I think we can use also the adjusting the water feed, Pak Wawan, if I'm not mistaken. So adjusting the feed of the water also can also prevent the corrosions instead of beside the explanations from Pak Wawan. I think that's my additional info, Pak.
Okay, thank you, Pak Hendra. I think because we already run out of time, so if you have any question, you can discuss it tomorrow. Okay, thank you so much for today, and we see you tomorrow. Good morning.
Okay, Pak. Good morning.